Hello, this is Sumit Bharadwaj from Azure Squad and I'm working under Cloud of Team. I'm DevOps engineer and today's my topic is chaos. In today's world, we heard every single technology is being created every single day. We heard that every single language, every new tool is being created every day. All thanks goes to our developers who's been immersed in these things and they are introducing all these things with us. And what happens is like when developers when developers and testing teams are developing or testing any single technology that they are being created, any single thing which they overlooked or just they ignored that led to a bug, and by using these bugs, any hackers will take advantage of it. And to counter all these things we have chaos bash, or we can say a chaos engineering to tackle all these things. So we can take one example, like you have recently heard about the Turkey, where a natural disaster happened. So every local companies or the companies who operate from Turkey, maybe they have their data center over there, so they affect their data centers. Also, they from if we will see from the security perspective, then there be any bug which which is just ignored by developers. So it will be for the very good opportunities for the hackers who take advantage of it, and then after that they will blackmail all this. To tackle all these things, we have a concept called chaos engineering, which basically a practice where you introduce a real world problem in your organization and see whether your organization is able to handle it or not. Suppose we have an example. You have a person, and this person have an opportunity or have given a task to create one system. This system will handle a nuclear power plant. Okay, then every single a single mistake can lead to a very big disaster. A million or a acre of lands will be become unhabitable, or a million of people will lose their lives. All this happens just because of simple mistake which is done by this person. So how you can tackle this? You have a chaos engineering. So what you will do, you will introduce every single real world problem with the system and see whether this system is capable to handle it or not. So you have one famous quote which is used by this chaos engineering, like this chaos engineering said that you have to find all the problem before the problem finds you. So this concept is based on all this concept is applied on this chaos engineering. So chaos engineering is just a practice, and these practice are this practice has a various branches, and we will be discussing about this branch which is called security chaos engineering. Our tool is based on security chaos engineering. So it is very important to understand security chaos engineering. So basically, security chaos engineering is divided into two parts. That is security plus chaos engineering. So what is it? So basically, security chaos engineering is like you are finding or you are finding all the vulnerabilities and weaknesses in your organization. So how it is done? It is done by chaos engineering. So chaos engineering is like you are failing your system before your system actually fails, and see whether your system is capable to handle it or not. So when we merge security with chaos engineering, is basically you are proactively introducing vulnerabilities and weaknesses in your system. Like what happens if in your organization there is a network outage? What happens if there is a hardware failure? What happens if there kernel failure? So all these are handled by itself or not? whether our developers or the testing teams or the security administrators are able to handle this or not. So what is happening? So we will find all the vulnerabilities by intentionally introducing all the vulnerabilities in our system. So if once it is finded by any security engineer or the developers that having any code issue in their applications, so they will they will encounter all these things and make the system make the system so advanced so that it will be withstand with its stand, so that it will be capable by capable so that in future if these same vulnerabilities face again, he will be the system will be handle it by its own without any interruption of any security engineer or any developers. So this is called chaos engineering, which is merged with security. Now every application, now we have seen that in today's world every single application or everything is moving towards the cloud. There are various numerous type of cloud we have, like AWS is also providing cloud, GCP, Google also provide cloud, and Azure also provides cloud, which is of Microsoft. So every single application is first containerized, and then with the help of this Kubernetes, which is an orchestration tool, it is a cloud native tool. So with this help, we just host our applications in one of these clouds. So what happens? This kiosk mesh is a tool, is a cloud native tools, or it is a project of CNCF. So it is a tool which which simulate all these faults in the Kubernetes or in the cloud both, and orchestrate all these faults in these Kubernetes or in AWS or in Azure. So we will be discussing about all these things because we are every single application is introduced in this cloud. So our real world problem which we will face will be around cloud. We introduce all the real world problems with the help of chaos mesh, and all these problems are with the help of this chaos mesh will be orchestrated and see whether our applications or whether our application which is in, whether it is in development, production, or the testing environment, they are able to handle it or not. So this is some point which I need to mention. But Chaos Mesh is providing, so it provides to stimulate. Third, it also give you the capability to introduce your self-made real world problem that might be faced in future in your Kubernetes hosted applications. So let's summarize all these architecture which is so far I have created. So let's summarize all this architecture which so far I have created. So I have started from the chaos engineering, which is basically a practice, and in this practice we have different sub practices, which is one of the security chaos engineering. Then I have moved into the all the real world problems which so far every single companies or organization as they are faced. We have also discussed one of the example of Turkey, and also we have discussed about our cloud native applications which so far we have used, so that we need not to manage our data center manually. So we just host our application in one of these cloud, and all the real world problem which have discussed is also faced in these cloud hosted application. So for these vulnerabilities, and for these real world problem, to introduce all these real world problem, we have chaos math which we have discussed, and these are some points through which we can achieve all these we can introduce all these problems with our cloud native application. Let's move towards our architecture, which we will see in our screen. Now we will discuss about the architecture of chaos mesh. So basically, chaos mesh is built in Kubernetes with the help of CRD, which is called custom resource definitions. and all the faults which we are discussing earlier, these faults are created in the form of CRD. For every single fault, we have different CRDs, and these CRDs are managed by different controllers. Like if we are try to introduce a fault on based on pod in which our application is running in our Kubernetes. So we have pod fault. For that pod fault, we have different CRD, and for that CRD, we have different controllers. So in this architecture, all these architecture is divided into three main components, which is chaos dashboard, mesh dashboard, chaos controller manager, and chaos daemon. Now, so far we have discussed all these components. Now we will be more discussing about every single component. So let's move towards chaos mesh dashboard. So this is our chaos mesh dashboard, which gives you a user-friendly interface from where you can see first page, which is called dashboard. Then we will be move towards workflow, where you will see every single fault which you have simulate. There you can see all your faults. Then schedules is the term schedule, where you will see your all scheduled faults and the experiments from where you can introduce any single any other fault which you want to introduce in your Kubernetes. And these are events which is happens when you have scheduled any of the faults which is given by chaos mesh default. Archive is like when you have used and you have finished your work, then all these faults will be comes under these archive, so that in future if you want to introduce it again, then you can use it from this archive side. And this is a setting from where you can manage all the setting of this chaos mesh dashboard. So this is chaos mesh dashboard, where you will see all your experiments so far you have done. It will be shown over there. Suppose you have done 4 experiments in your past, then it will be shown there. And if there is currently ongoing any fault, then it will be show over there. So in the dashboard you have one icon called workflow, where you will see all your faults matrices, where you can you can see all the logs of your faults. And chaos mesh also give you a tutorial. When you go into this link, then it will show you different tutorials so that you can understand it in a better way. Second, start with workflow. You can see all the workflow of the multiple experiments. You can see now if you want to introduce your faults, that is you have been created, you are working on some fault which is not created in this chaos mesh, and you want that your fault will be introduced in this chaos mesh, and from chaos mesh you can introduce it in Kubernetes. So you have the chaos mesh also give you that opportunity, so that you can simulate your faults with the help of this. From the schedule part, you can mention your YAML files so that you can introduce it. So the next component is chaos controller manager, which is called a brain of our chaos mesh. So what basically done by the chaos controller manager? So it is basically responsible for every single fault which you want to schedule it, and it over there you have various controllers which controls our chaos faults which we want to introduce, and which basically you have created CRD for them. So for chaos controller manager, you will be you will not directly connected with this chaos controller manager. You are connected with the API server. Then from API server you will went to chaos controller manager. The next part is our chaos daemon, which is runs as a daemon set in every single node in our Kubernetes cluster. And what is the work of daemon? Is chaos daemon is to inject any chaos or the for which intention we have introduced our pod. So what basically done chaos is like it will interfere with our node settings, or with our node file system, or with our networking kernel, and done every single thing which is introduced by this pod, which we have introduced earlier. one more functionality is given by our chaos mesh dashboard, which is called manage user permissions. So suppose your any application is running on in your production namespace in Kubernetes. So you don't want that your chaos mesh experiment will be done in the production. So what you will do, you will manage all your permissions of your chaos mesh or your user who is using this chaos mesh, and done the chaos in your Kubernetes cluster from these RBAC, which is called role based access control in our Kubernetes. So with the help of RVEC, it will limit your zone through which in that namespace only you can do every single chaos. If you try to done chaos into the other namespaces, it will not be introduced and it will give you some type of error. The all the workflow is divided into the three parts. So first is the user operation or the user input, where user will introduce any type of fault in our Kubernetes cluster, and all these fault or the CRDs which we want to introduce, it will be gone through the API server, and then when API server is validate it, and then it will go to Kiosk Controller Manager. This controller manager. So the next part is where you will be scheduling, you will be monitoring all your chaos with the help of chaos control with the help of your chaos mesh dashboard. So in that thing, it chaos controller manager helps, where your chaos controller manager will use different controller or the controller of the same fault which you have used. So with this controller, you are able to schedule that fault to in your cluster. When that fault is introduced in your cluster in the form of pod, it will start working by giving command to the kiosk daemon. So we will be discussing our third point, which is injection in a node, in a specific node. So in this, chaos daemon will perform a important role, where chaos controller manager gives the component chaos controller manager component gives command to the chaos daemon, and this chaos daemon will perform hacking in a particular or a target pod namespace, and done the specified fault, which is for which we have introduced our chaos controller manager component. Let's summarize all this architecture. Begins with from where the user use the chaos mesh dashboard, from where he introduced any fault or any fault which we want to try in our cluster. So he will use one of the CRD which is being created in our API server, and all these API server, all the flow will go to our chaos controller manager, where various type of controllers are stored. Using that controller, our component is being created in our cluster as a pod, and these pods will give command to our chaos daemon, and this chaos daemon will inject the particular fault in the target pod namespace, and do all the specified faults. Now let's discuss some benefits which we have far discussed in this video. So the first benefit is improve the system resiliency. So as chaos mesh allow you to identify your vulnerabilities and weaknesses in your system. Once you find all these vulnerabilities and weaknesses, you can take a proactive step, so that you can improve your resiliency. And because of this chaos mesh, you can take further steps and introduce more vulnerabilities and weaknesses, so that once all these finds, you can improve your system quality or improve your system performance security, so that in future, if it is faced again, then your system will withstand itself or handle it itself. So let's discuss the second point, which is test disaster recovery. So you have recently heard, or we have discussed earlier, the Turkey situation where natural disaster happens. So if they are not prepared for that disaster or natural disaster, so they haven't prepared the backup plan or the recovery plan. So with these chaos math tools, you can prepare yourself for these kind of situations where your system or your data centers, you lost your data centers, and now in this situation your whether your recovery, your disaster recovery is working fine or not. Now third benefit is like, if you want to avoid downtime or reduce the risk, then this chaos mess for this tool is for you. So this experimental Saturday task helped me a lot to improve my searching abilities and grasping power. So this process will help me in future, as well as from the customer perspective, because I'm able to achieve every single work which is given by the customer in a very fast pace, because in past, when I follow these processes, I have prepared so much. So in the end, I'll suggest, I'll tell you that these experimental Saturdays are very good because it improve your capability, increase your capabilities to understand every single new topic, or every single changes, new technologies are introducing every day, and this experimental Saturday gives you an ability, so that you can you will be walking with this world in the in this world where new technologies are introduced.